So one thing that we talked about in a previous lesson where we were working on confidence intervals for population means is that we know that if we want to increase the precision or the accuracy of our confidence interval, but not sacrifice our level of confidence, then what we need to do is to increase the sample size. So now we're going to be talking about, well, how can we find out just how small the sample can be so that we can still have a certain level of confidence? Because remember, you don't want to just increase your sample size indefinitely because that's going to be expensive in the real world. It means you have to survey more people. It means you have to collect more data, and it's not always very easy to collect data. So given a C confidence level, and we have a certain margin of error that we want to be within, the minimum sample size that we needed to estimate P is N, remember we're talking about sample size here, equal to P hat multiplied by Q hat multiplied by the critical value Z sub C divided by your error, and all of that is squared. If that doesn't come out to be a whole number, then we will add up. And notice that in this formula, we do have to put in estimates for P hat and Q hat based off of the problem. If we do not have any preliminary estimates, if we don't know what those are, then we're going to use 0.5 for both of them. So we're going to use P hat equals 0.5 and Q hat equals 0.5 if we do not have estimates. So now let's look at an example where we determine the minimum sample size. So let's say that you're running a political campaign and you want to estimate with 95% confidence the proportion of registered voters that will be voting for your candidate. And you want your estimate to be within 3% of the true proportion. This sentence right here is very important because when they tell us what we want to be within, that is giving us our margin of error. So we're saying that E is equal to 3%. And 3% written as a decimal is 0.03. Divide that 3 by 100. We're going to find the minimum sample size needed when first no preliminary estimate is given. So if no preliminary estimate is given, we still use the formula that we have above, that sample size is P hat times Q hat times the critical value Z sub C divided by the error all squared. But with no preliminary estimate, we're using 0.5 for both P hat and Q hat. The critical value that corresponds to a 95% confidence interval is 1.96. We've seen that earlier in this lesson. It's also in that standard normal table of critical values. And the error that we're using is 3%, which is 0.03 squared. No, which is 0.03. And then I will square all of that fraction. This gives me approximately 1067.11, which is not a whole number. So that tells me that I am going to need at least 1,068 people in my sample size in order to get an estimate that's within 3% of the true population. Now let's say that we do start off with a preliminary estimate of 0.31, like in part B. Well, if P hat is 0.31, then Q hat, which is 1 minus P hat, is 1 minus 0.31, which comes out to be 0.69. So now I will start again using the formula P hat times Q hat. So P hat is now 0.31. Q hat is 0.69. And I hope everyone sees what formula I'm using. I'm using the same formula that we used before. It's just that this time we have different values for P hat and Q hat. So P hat was 0.31. Q hat was 0.69. The critical value is still 1.96. We're still working with a 95% confidence level. And our margin of error is still 3%, which is 0.03. And we still need to square that last set of parentheses. To see, here we get approximately 913.02. So if I have this preliminary estimate of 0.31, then I know I will need at least 914. And I should have wrote this on the first one, but we are talking about registered voters. That's how big our sample size would need to be, or bigger, to be within 3% of the true population with 95% confidence. Now on the next slide, you will try a very similar example where you're going to be estimating within 2% with 90% confidence. And you will do it two different ways. One, if you have no data starting off, or two, if you do have some data starting off that gives you a sample proportion to start with.